I spent 3 decades staring at equations that all pointed to the same impossible conclusion. Time isn't what you think it is. It's not a river flowing at the same rate for everyone. It's not absolute. It's not fair. And the strangest part, the part that kept me awake at 3 a.m. in my Cambridge office, is that this revelation doesn't come from exotic physics or quantum mechanics. It comes from the speed limit, the cosmic speed limit, the one thing everyone accepts but almost no one truly understands the implications of. The speed of light is 299,792,458 meters per second. Not approximately. Exactly. In every direction, at every moment, no matter who's measuring or how they're moving, that number isn't just a speed, it's the rate at which reality itself propagates through space. And buried inside that constant is the most profound thing I ever discovered about time. It doesn't exist the way you experience it. Your now is not my now. Your future is someone else's past. And the universe doesn't just allow this, it demands it. Let me show you why. In 1967, when I was still walking, still working at my desk without assistance, I attended a lecture where someone mentioned time dilation as a curious side effect of Einstein's relativity, a mathematical oddity, something that happened to particles in accelerators but didn't really matter for understanding time itself. I remember thinking how wrong that was, how completely backwards. Time dilation isn't a side effect. It's the main event. It's reality teaching us what time actually is. Here's the thought experiment that changed everything for me. Imagine a train. Not an ordinary train, a superfast train traveling at 90% of the speed of light. You're standing on the platform watching it pass. Inside that train is someone your age, with a watch identical to yours, both of you starting at the same moment. From your perspective on that platform, you watch their watch tick. But it's ticking slowly. Not a little slowly, dramatically slowly. At 90% of light speed, their time passes at about 44% of the rate yours does. If an hour passes for you, only about 26 minutes pass for them. This isn't an illusion. It's not a measurement error. Their time actually passes more slowly. If they traveled for what they experience as 1 year and returned, more than 2 years would have passed for you. They would have aged less. Their biology would have progressed through fewer moments. They would have had fewer heartbeats, fewer thoughts, fewer seconds of existence. People always ask me if this is just relative, if from their perspective, you're the one moving slowly. And yes, while the train is moving at constant speed, they see your time moving slowly too. That's the reciprocal nature of relative motion. But here's the crucial part, the part where it gets truly strange. When they turn around and come back, the symmetry breaks. The one who accelerated, who changed direction, is the one who aged less. This isn't philosophy. It's been measured. In 1971, scientists put atomic clocks on aircraft and flew them around the world. When they landed and compared them to stationary clocks, the traveling clocks showed less elapsed time, billionths of a second less, but measurably, definitively less. The universe doesn't care about our intuition that time should be universal. It simply isn't. Now, let's go faster. At 99% of the speed of light, your time passes at only about 14% of the rate it does for a stationary observer. 1 of your years equals 7 of theirs. At 99.9% of light speed, the ratio becomes even more extreme. 1 of your years equals about 22 of theirs. At 99.99%, 1 year for you equals 71 years for everyone else. The curve doesn't just slope, it goes nearly vertical as you approach light speed. At exactly light speed, if you could somehow travel at that speed with mass, time would stop completely for you. Not slow down, stop. Zero passage of time. Infinite time dilation. This is what I realized in those early years, what I spent decades exploring. Time isn't dilating as some secondary effect of motion. Motion through space and motion through time are fundamentally linked. They're not separate phenomena. When you move faster through space, you must move slower through time. It's not that the speed of light causes time dilation. The speed of light is the manifestation of how space-time actually works. Think of it this way. Everything, you, me, light, particles, planets, is always moving through space-time at the same total speed. Not through space, through space-time. When you're sitting still, you're moving through time at maximum rate. You're traveling into the future at 1 second per second. But start moving through space, and that motion has to come from somewhere. It comes from your motion through time. Move faster through space, move slower through time. The total always adds up to light speed. Light itself moves through space at maximum speed, so it doesn't move through time at all. From a photon's perspective, if it had one, no time passes. A photon emitted from a distant star and a photon emitted from a lamp in your room experience exactly the same subjective duration between their creation and absorption, none. To the photon, emission and absorption are the same moment, even if billions of years separate them from our perspective. This was the discovery that haunted me. Time is local, personal, dependent on your motion and the gravity you're experiencing. There is no cosmic clock ticking away somewhere, no universal now against which everything can be measured. When you look at the stars, you're not seeing them as they are now. You're seeing them as they were. And because of the finite speed of light, there's literally no way to know what now means for a distant star. The question itself is physically meaningless. I remember explaining this to a journalist in 1988, and they asked, "But surely there must be some underlying absolute time, even if we can't measure it." No, there isn't. Not as an assumption, as a fact. Relativity isn't a theory about measurements and perspectives. It's a theory about what time actually is. And time is not absolute. It never was. Here's where it connects to the cosmic speed limit in a way most people miss. The reason nothing can exceed the speed of light isn't really about speed at all. It's about causality. It's about the structure of time itself. If you could send information faster than light, you could send it into your own past. Not in some vague philosophical sense, literally into your past. You could create closed time-like curves. You could receive a message before it was sent. This isn't speculation. It's a direct mathematical consequence of faster-than-light travel in special relativity. Let me walk you through why. Imagine two observers moving relative to each other at high speed. Events that appear simultaneous to one observer do not appear simultaneous to the other. What one sees as happening at the same moment, the other sees as happening in sequence. Their nows are different. Now, suppose you could send a signal faster than light. You send it to someone moving away from you at relativistic speed. From your perspective, you sent it forward in time. But from their perspective, given how their time axis is tilted relative to yours, they receive it in their past. If they send a faster-than-light signal back to you, it arrives in your past. You receive the reply before you sent the original message. The universe forbids this, not because it's weird or paradoxical in some abstract sense, but because it violates causality. Effect would precede cause, and causality is the foundation of everything. Without it, physics doesn't work, logic doesn't work, existence doesn't work. The cosmic speed limit exists precisely to protect causality. Light speed is the speed at which cause propagates to effect. It's the speed of causality itself. This is what I meant when I said the speed limit isn't really a limit on motion. It's a structural property of time. Space and time are woven together, and light speed is the conversion factor between them. It tells you how much space equals how much time. 299,792,458 meters of space equals 1 second of time. That's not arbitrary. That's the geometry of reality. By 1985, I'd explored these implications enough to make a bet with Kip Thorne. Not about time dilation, that was settled science, but about whether black holes, the most extreme warping of space-time imaginable, preserve information or destroy it. I bet they destroyed it. I lost that bet in 2004 and paid up with a baseball encyclopedia. I was wrong about information, but the process of being wrong taught me something crucial. The universe is consistent. Fiercely, absolutely consistent. It won't bend its rules even in the most extreme conditions we can imagine. If causality must be preserved, it will be preserved. If time must be local and relative, it will be local and relative. No exceptions. This consistency is what makes time travel so problematic. Not impossible necessarily, but constrained in ways that prevent paradoxes. In 1990, Kip Thorne and his colleagues showed that traversable wormholes could theoretically allow time travel. I spent months examining their work. Brilliant physics. But here's what I realized. Every solution that permits time travel to the past requires either exotic matter with negative energy density, which we've never observed in the required quantities, or a naked singularity, which is likely forbidden by cosmic censorship. The universe seems to protect itself from time travel paradoxes by making them extraordinarily difficult or impossible to construct. But travel to the future? That's easy. Trivial, even. You're doing it right now at 1 second per second. Speed it up by moving fast or getting close to a massive object, and you travel to the future faster. Not metaphorically, literally. A twin traveling near light speed for what they experience as 10 years returns to find Earth has aged 50 years, or 100, or 1,000, depending on how close to light speed they traveled. They've traveled to Earth's future. They can't go back, but they've absolutely traveled forward through time. This asymmetry fascinated me. Forward time travel is not only possible but mandatory. Time dilation is an observed fact. Backward time travel seems forbidden, or at least so difficult that the universe might as well have posted no entry signs. And the speed of light is the gatekeeper for both. It determines how much forward time travel you can achieve through motion, and it prevents backward time travel by protecting causality. In 2006, I gave a lecture where someone asked whether future civilizations might find a way around the light speed limit. Some loophole we haven't discovered. I said then what I still believe. The laws of physics aren't suggestions. They're not challenges to be overcome. They're descriptions of how reality operates at the deepest level. We can't choose to have different laws any more than we can choose to have triangles with 4 sides. The cosmic speed limit is built into the fabric of space-time itself. But there's something people miss when they focus on that limit as a restriction. It's also a connection. The fact that light speed is finite and constant means information can propagate. Cause can lead to effect. Events can influence each other. If light speed were infinite, if changes propagated instantaneously, time wouldn't exist as we understand it. Everything would be simultaneous. There would be no causality, no sequence, no story of the universe unfolding. The finite speed of light is what gives time its structure. And that structure is stranger than anyone imagined before Einstein. Your time is not my time. The past isn't fixed in the sense of being the same past for all observers. The future isn't open in the same way for someone moving at high speed as for someone stationary. The present moment, the razor's edge of now, extends only to your immediate location. Beyond that, simultaneity dissolves into relativity. I spent decades living with this. As my body stopped responding, as my motion through space became slower and slower until I was effectively stationary, I had a lot of time to think about motion through time. In a strange way, my physical limitations gave me a fixed reference frame. While others traveled, I stayed put. I watched their time and mine diverge microscopically, nothing meaningful at human speeds, but conceptually profound. The universe doesn't distinguish between my time and yours in any absolute sense. There's no cosmic judge deciding whose clock is right. Every clock is right from its own perspective. Every observer's measurements are valid, and yet they don't agree. They can't agree because the structure of space-time itself won't allow it. Time is local, personal, fundamentally tied to motion and gravity. This is what I discovered that people still don't talk about enough. Not time dilation as a curiosity, not relativity as an exotic edge case, but the fundamental reconception of time itself. Time isn't a stage on which events occur. It's part of the theater. It warps, stretches, bends. It passes differently for different observers, and that's not a bug in our perception. It's reality. The cosmic speed limit enforces this, protects it, makes it inescapable, and in doing so, it reveals what time actually is. Not a separate dimension flowing uniformly, but an inextricable component of space-time, experienced differently by every observer, yet connected through the universal constant of light speed. I meant it when I said this changed everything. It changed how I thought about cosmology, about black holes, about the beginning and end of the universe. But more than that, it changed how I experienced my own existence. Sitting still in my chair, I was traveling through time at maximum rate, moving into the future at 1 second per second, the same rate as light moves through its trajectory, though for light there is no time, the same rate that defines causality itself. We are all time travelers, every moment, every breath, every thought, moving forward through time, tied to the cosmic speed limit that structures reality, unable to go back, unable to exceed light speed without infinite energy, but absolutely undeniably traveling. The speed of light doesn't just limit our motion through space, it defines our experience of time. And time is not what you think it is.